streaming because skill issues. All right, so last time we got through we got through 2.4. We finished the function section in OCaml Programming, correct and efficient and beautiful. It's CS3110 is usually what you'll see people call it, and there it is. And let me just pin that at the top for anybody that cares about it. We're basically just going through this book somewhat quickly, mostly focusing on things I don't know that well, and then spending more time on those things anyway. We're not reading it word for word by any means. So let's keep going. Documentation. Let's go. Let's see. OCaml provides a tool called OCamlDoc that works a lot like Java's JavaDoc tool. It extracts specially formatted comments from source code and renders them as HTML, making it easy for programmers to read documentation. 2.5.1, how to document. Here's an example of an OCamlDoc comment, right? So this part I know, doc comments, you throw in an extra star, similar to Rust, actually. Very similar. The double asterisk is what causes the comment to be recognized as an OCamlDoc comment. The square brackets around parts of the comment mean that those parts should be rendered in HTML. Hey, Leandro, how's it going? Hope you're doing well. We're just reading through CS3110, not word for word, you know. Dude, I bet it's getting late, and you've had a full week. Hopefully you can get to bed soon. The square brackets around parts of the comment mean that those parts should be rendered in HTML as typewriter font, right, rather than the regular font. Yep. I've done this a little bit for my Mint PR. Let's go. Mess with OCamlDoc comments. So most of this, I understand this pretty well. OCamlDoc supports documentation tags such as @author, @deprecated, @param, @return, etc. For example, in the first line of most programming assignments, we ask you to complete a comment like this. @author, your name, your net ID. For the full range of possible markup inside an OCamlDoc comment, see the manual. How about that? Okay. Documentation style we favor in this book resembles that of the OCaml standard library, concise and declarative. That's one way to put it. As an example, let's revisit the documentation of sum. Sum list is the sum of the elements of list. It's fine. That comment starts with sum list. Yes, okay. But is emphasizes the mathematical nature of the function. Okay. Note how there is no need to add togs, how about that, to redundantly describe parameters or return values, as is often done with JavaDoc. Everything that needs to be said has already been said. We strongly discourage documentation like the following. Yeah. I wonder who they're targeting here. I mean, this is actually somewhat common even outside of JS, but wow. Can you imagine doing this for a strongly typed language? Hey, Ninja, what's up? Of course, now everybody just writes the other one, the one with types, with fake types, right? Typey script. That poor documentation takes 3 needlessly hard to read lines to say the same thing as the limpid, huh? 1-line version. What's this annotation on limpid? Adjective of a liquid, completely clear and transparent. Somebody added that annotation because they were like, what is this word? Yeah, I don't think I've ever used that word in my life. And I've used some words, let me tell you. There is one way we might improve the documentation we have so far, which is to explicitly state what happens with empty lists. Yeah, that's fair. Here are a few more examples of comments written in the style we favor. Raises is a good one. But really, I like the Jane Street thing of just putting what do they add? EX C or something like that. Suffix to any function that actually throws an exception. I like that. It's penned in Nunes. The documentation of index specifies that the function raises an exception. Yeah. Sure. So yeah, sure. The requires. Sure. Sure. Yep. Don't need to specify comments in doc strings. How about that? OCaml has built-in printing functions for a few of the built-in primitive types: print char, print string, print int, and print float. There's also a print inline function, which is like print string, but also outputs a new line. Okay. That's good to know. I usually use print line for most things for obvious reasons. Let's get our REPL up. I don't think I did that yet. Interesting. Oh, I went to the wrong one. I was like, well, this does not look right. MA. Okay. Really? You're not going to work that way? Okay. That's fine. Here we go. Cool. Print int 5. There we go. How about it? Print inline. Hey. Yeah. Exciting. Of course, in the REPL, I don't know. I guess, yeah. I guess there is a difference. Right. Okay. It does show the new line in the REPL. Good to know. Unit. Let's look at the types of a couple of those functions. Print inline, string to unit. Yep. They both take a string as input and return a value of type unit, which we haven't seen before. I have. There is only one value of this type, which is written parens, and is also pronounced unit. So unit is like bool, except there's one fewer value of type unit than there is of bool. Unit is used when you need to take an argument or return a value, but there's no interesting value to pass or return. It is the equivalent of void in Java and is similar to none in Python. Unit is often used when you're writing or using code that has side effects. Printing is an example of a side effect. Yes, very important to know. Semicolon. If you want to print one thing after another, you could sequence some print functions using nested let expressions. Okay, sure. Using underscores to not have to use a name. We could also write let unit. Yeah, I've seen this a lot actually in OCaml code, where they'll just use let unit for things that return unit. That's fair. But either way, the boilerplate of all the let in is annoying, so to have to write. So there's a special syntax that can be used to chain together multiple functions that return unit. The expression E1, E2 first evaluates E1. Okay, so it's basically special syntax if you're returning unit is you don't have to have the let. I don't think I actually knew that. You can just do print inline semicolon. Okay, reasonable. Yeah, semicolon is a statement separator, not a statement terminator. All good. Ignore. If E1 does not have type unit, then E1, E2 will give a warning because you're discarding a potentially useful value. If that is truly your intent, you can call the built-in function ignore to convert any value to unit. Sure. So ignore 3, 5. Yep. Printf. Use printf. For complicated text outputs, using the built-in functions for primitive type printing quickly becomes tedious. For example, suppose you wanted to write a function to print a statistic. Sure. Java, let's go. Here's how we'd use printf to re-implement print stat. Name num, printf, %s, %f / n %. Name num. Oh, because they're doing a conversion. The first argument to function printf is this format specifier. It looks like a string, but there's more to it than that. Very, very true for anybody who was here when I was working with Mint. It is not a string. I can tell you that much. It's actually understood by the OCaml compiler in quite a deep way. Inside the format specifier, there are plain characters and conversion specifiers, which begin with %. Okay, let's just see what this is. It starts with %s, which is the conversion specifier for strings. Yep, I know that. Plain characters, %f. That means the next argument of printf must have type float. Okay, figured it was a float. Then the new line, and then the conversion specifier means to flush the output buffer. I always forget that with printf type functions to do the whole flush thing. Yep. I sure. And then sprintf, which collects it to string. So that's like format and Rust. And there you go, printing. Exciting. Debugging is the last resort when everything else has failed. Let's take a step back and think about everything that comes before debugging. Okay. Rob Miller, 4 defenses against bugs. Make them impossible. Yay. Use tools that find them. Sure. Make them immediately visible and extensive testing. Okay, sure. How to debug. Distill the bug into a small test case. Okay. I think we know how to debug. Debugging in OCaml. There we go. Print statements. Print line debugging. We all know it's the right way to go. Suppose you want to see the trace of recursive calls and returns for a function. Use the trace directive. Yep. Okay, cool. If you evaluate fib2, you will now see the following output. To stop tracing, use the untrace directive. Okay, cool. I don't remember if I knew about trace. OCaml has a debugging tool, OCaml debug. Yeah, I doubt that's going to be worthwhile. Emacs mentioned. Let's go. Use Emacs. That's what this just said. Okay. Defensive programming. As we discussed earlier in the section on debugging, one defense against bugs is to make any bugs or errors immediately visible. That idea connects with the idea of preconditions. Consider the specification of random int. Sure. I don't know if I actually care about this right now. Let random int bound equals assert bound. Okay, so using an assert. Using an if. Using an exception. Okay. Sure. Yep. There you go. 2.8 summary, syntax and semantics, terms and concepts. Okay. Think we're good on this. Exercises. All right. Let's do some exercises, I guess. Solutions to most exercises are available. Fall 2022 is the first public release of these solutions. Though they have been available to Cornell students for a few years, it is inevitable that wider circulation will reveal improvements that could be made. Please make contributions through GitHub. Okay, exercise values. What is the type and value of each of the following OCaml expressions? 7 times 1 plus 2 plus 3 int. CS caret string of int 3110 string. I don't think we need to worry about that. I guess we'll just do it for fun, for funsies, for the people at home. Int. Yeah, we're good. CS caret string of int 3110. Yay. Examine the table of all operators in the OCaml manual. You will have to scroll down to find it on that page. Write an expression that multiplies 42 by 10. I don't think that will be a problem. Write an expression that divides 3.14 by 2.0. 3.14 2.0. There. Typed an extra character. I don't know what I was thinking. Write an expression that computes 4.2 raised to the 7th power. There's no built-in integer exponentiation. I believe it is ** dot. I don't remember for sure. No. Oh, that's right. There's no dot. And you have to do 7 dot. Yeah. So it was funny. I was reading the other day, like, that base fixes this basically. So Jane Street's base is kind of like the replacement of the standard library, right? And so instead of that, they first of all have integer exponentiation exposed. So ** is just integer exponentiation with base. And then they also use ** dot for float exponentiation. Pretty reasonable. Pretty reasonable. Exercise equality. Write an expression that compares 42 to 42 using structural equality. Okay. Sure. We'll do these real quick. 42, 42. Yay. High. High. That'll be true. And then high double equals. Never use that, by the way. Using physical equality. I'm going to guess this is false. Yeah. There you go. It is not the same actual item. Okay. Exercise assert. Enter assert true, enter assert false. Okay. Write an expression that asserts 2110 is not structurally equal to 3110. We can do that. So that should just return unit. This should be an exception, I would guess. Yeah. And then assert. I mean, we can do this. Is it just 1% or 2? I always forget. No, not percent. That's it. 2110 equals 3110. I think that'll work. Nope, syntax error. Is it just one at? Am I just like completely wrong here? Is this not at all how it works? What's the like right application operator? I guess I'll just use parens. Dude, man, what's up? Okay. Assert failure. That's what we wanted. I thought it was at. Am I crazy? Probably. It's fine. We are doing some OCaml. Kind of. I mean, we're learning out. Like, I mean, I've written OCaml, but you know, we're doing some foundation stuff, making sure that I don't have any surprises here. Yep, exactly. I've written I've written parts of this book. Not what I meant. I've read parts of this book here and there, but I've never like read the whole thing. So that's what I'm doing. Write an if expression that evaluates to 42 if 2 is greater than 1 and otherwise evaluates to 7. Okay. Oh, control U is not. That is not how you clear this, by the way. Unlike closure. Okay. Sure. So if 2 is greater than 1, then 42 else 7. Whoa, did not expect that. All right. Using the increment function from above as a guide, define a function double that multiplies its input by 2. For example, double 7 would be 14. Okay. Let double x equals x times 2 and double 4. Yay. It's really funny. More fun. Define a function that computes the cube of a floating point number. Test your function by applying it to a few inputs. Sure. So yeah, double function. Let's go. All right, so let cube x equals x star star. No, there's no dot. Always gonna get me. 3. Yes, I do mean 3 dot. Cube 1 dot. Cube 4 dot. Okay. Define a function that computes the sign 1, 0, or -1 of an integer. Use a nested if expression. Test your function by applying it to a few inputs. Oh, really? Def. No, I did def. That's funny. Let's sign x equals if. I mean, guards would be really nice. I am doing it to make sure that I'm not like completely freaking wrong about everything in my life, right? If x is less than 0, then -1, else if x is greater than 0, then 1, else 0. Okay, sign -5. Hey. This expression has type int, but an expression was expected. Oh, is negative like this? Is that it? Yeah. Forgot about that. Sign. So am I wrong? Is it not at? No, it is. It just didn't work for... What did that not work for? Assert? Assert didn't like at. Yeah, you can't use at with assert. There's probably a reason. There's probably a reason. How about it? I know how to write a function. Right, yeah. Minus is technically a function. Define a function that computes the area of a circle given its radius. I don't remember how to do that. I don't care enough about that one. We're gonna leave off that third one and say, you know what? I probably know how to define functions in OCaml. I've done it a few times. Exercise RMS. Define a function that computes the root mean square of two numbers. Yeah, I don't want to do math. I mean, even this is like, why? I guess it's fine. I guess it's just like getting the operators down. Square root of x squared plus y squared divided by 2. Sure. So RMS mentioned. Who knew? Who knew? Literal FSF. I know. Like dog whistling right here, right? Little RMS dog whistling. All right. What am I doing? Let RMS equals okay, I figured it was square root. So I want square root. I want this is really annoying. I guess it might help if I put my, that would be pretty funny. Okay, how do I want to do this? Square root at and then x squared plus y squared. So that's what's really annoying is, oh yeah, let's just do it this way. Instead of that, we're just going to do x times x, so we don't have to deal with the fact that we don't have integer exponentiation. And then we'll do y plus y. And then I guess we'll just do this to be lazy and say divided by 2. Let's see if this works. Expression is type int, but an expression was expected of type float. Is square root? What is square root? Square root. Float. Oh, so it wants a float anyway. Interesting. Okay, that's fine. So we'll just do this. I mean, it did just say two numbers. It didn't actually say that they have to be integers, but we'll just pretend that they have to be integers. And then we will say float of int. And I don't know if this is actually going to work correctly. Int float. Okay. Looks like, oh yeah, because of the way I did parens, this is actually perfect. Okay. So then RMS 3.6. Sure. We're going to pretend that's right. Doesn't do the circumference days after pi day. No more pi for you. Rough. I like pi. Date fun. Nobody thinks dates are fun, okay? Define a function that takes an integer d and string m as input and returns true. Just when d and m form a valid date. Here, a valid date has a month that is one of the following abbreviations, and the day must be a number that is between 1 and the minimum number of days in that month inclusive. Oh dear. Are we really going to write this right now? For example, if the month is Jan, then the day is between 1 and 31 inclusive, whereas if the month is Feb, then the day is between 1 and 28 inclusive. I don't think I'm going to do that one either. It's not going to teach me anything, and it's just going to be annoying. How about that? Define a recursive function fib int to int such that fib n is the nth number in the Fibonacci sequence, which is 1, 1, 2, 3, 5, 8, 13. That is fib 1 equals 1, fib 2 equals 1, and fib n equals fib n minus 1 plus fib n minus 2 for any n greater than 2. Test your function in the top level. We could do this, but they literally just wrote like the function for us. I know. I like I mean, I'm doing this so that I can actually learn things that I don't already know. I don't think writing this fib function is going to actually teach me anything. It's just going to make me annoyed and make this take longer. How quickly does your implementation of fib compute the 50th Fibonacci number? That's because you need to use an accumulator. Use an accumulator. It is content. You are correct. Let's just see. I'll do one. Maybe I can do one harder exercise from this thing, and then we'll, before we move on. Maybe we'll see. We'll see. Let's just finish, and we'll choose a hard exercise. Hard exercise. Yeah, that's why they're talking about this. And is near. Is because basically they're saying if you didn't write your fib in a way that is tail recursive, then you should write fib fast and make it tail recursive. What is the type of each of the functions below? You can ask the top level to check your answers. Okay, let's see. Let f of x equals if x, then x, else x. I would say that would be a bool to bool. Let g x y, if y, then x, else x. That one should be a alpha to bool to alpha. X, y, z, if x, then y, else z. This should actually be the same as the above. I don't think it'll automatically, it won't make it like a variant type or anything automatically, right? Yeah, no, I don't think so. I think it'd be pretty much not typical. Let I x, y, z, if x, then y, else y. Huh. I wonder what will happen there. I would imagine that they would just consider z. I guess they might give it a type parameter. I guess it'll probably be bool to alpha to beta to alpha. That would be my guess. All right, let's see what happens. Let fx equals if x, then x, else x. Bool bool. Yay. Let g x y equals if y, then x, else x. Alpha to bool to a. Yep. Got that one right. Let h x y z equals if x, then y, else z. What did I say this would be? It should be the same. A bool alpha. Okay, well, the other way around. It's fine. X is the bool. Bool to A to A to A. Yeah. It's all right. Okay, I didn't say it right, but I was right in my head, okay? All right, and the next one should, I think it'll be bool to alpha to beta to alpha, but I could be wrong. I'm right. I am so right. All right. Very good. Type inference. How about it? Divide. Write a function divide numerator float to denominator float to float. Apply your function. Okay. I guess they just mean this. Let divide num d equals n slash d. Wrong places to put the dots. Do they really mean just that? Or do they mean something I don't understand? Write a function divide. Apply your function. Sure. I don't get why this would be a thing. I guess I can look at annotations. Oh, they just want you to use name parameters. And like, but that's unnecessary. I mean, it's fine, but like, why? Why'd you do it? Okay. Fine. Sure. Associativity. Suppose that we have defined let add x y equals x plus y, which of the following produces an integer, which produces a function, and which produces an error. Decide on an answer, then check your answer in the top level. I don't think we're going to have to check. That's going to be an integer. That's going to be a function. This one, I believe, will be an error. I guess we'll check for the sake of that. And this one should be an integer. Okay. Let add xy equals x plus y. Add 5, 1 is an integer. Add 5 is a function. Add 5, 1 should be a syntax error. What? It works? Oh, that makes sense. Oh my God. I'm silly. I'm silly because it just returns a function. You're just saying you want to do that first. But it's just the same thing. I'm silly. Add 5, 1. I guess add 5, 1 actually, I don't know if you can do that. I know you can do this, right? I know that works. I don't know if it works like this. No, because the parens are a type of, it's interpreting that as application. Okay. I was wrong. How about it? That's why we're here, folks. That's why we're here. Okay, exercise average. Define an infix operator plus / dot to compute the average of two floating point numbers. Okay, that sounds fun. Believe we just, well, if I could remember where my symbols are that I type all the time. I think I just do this. And it computes the average of two floating point numbers. And then, so that's just adding and dividing them, in case you weren't sure. We'll just do it like this. X plus y divided by 2, because I don't remember operator precedence, but we could try it the other way too. And then we should be able to say 1. Oh, I messed up. This expression is type int, but an expression was expected of type float. That's because I forgot the dot there. And I forgot the dot here. Yeah, classic. Okay, so 1.0 plus 2.0. 1.5, let's go. Our own operator. Okay, let's see what happens because of precedence. I wonder what this is going to do. Yep. It's wrong. It is in fact wrong. Because division has higher precedence, as you would expect. Okay. Hello world. Type the following in UTOP. Notice the difference in output from each. We already did this, so I'm not going to do that again. All right. Should we do the Fibonacci thing, or do people not care? That's right. I'm leaving it up to whether chat answers right now that I should do it. Dang it. I should have put a time limit on it that was less than the delay. All right. OSS. I already have a place for this. I even have it open right there. It's in Learn OCaml. Can meta do tail call? I think so. Okay. We'll just put it in my code.ml. How about that? Okay, let's go back up to the thing and copy it. I mean, sure, we can do this. That way I don't have to keep going back and forth. I haven't defined a Vim keybind for that yet, so we have to do it the Emacs way. Sure. So if we say let fib, there is the nice guard syntax, but I'm trying to remember how the guard syntax works in OCaml. I like the guard syntax. Is it literally just like let fib, like, and then you put your guards? I can't remember right now. I don't think that's actually how it works. Maybe you have to define your arguments and then put your guards. That would kind of make sense. I think it might be without the argument. Hey, Brib. Thanks. The funny part about posting a bunch of selfies on the Zitter lately, a bunch as in like 3, is that, you know, people that don't actually come to my stream probably, well, they might not actually know I'm joking, or they might not know that's not like how I always present myself. Okay. Is this valid syntax? I think it is. We'll just keep going for it. So 1 is 1. I'm gonna say, since this was happy about my guard, 2 is 1. And n is, first of all, this has to be recursive. N is fib n minus 1 plus fib n minus 2. Yeah. Plus fib. It's literally right above, and I was still trying to read it. Sorry about that, guys. Let's see. Fib n minus 1 plus fib n minus 2. I still went back to the browser. Unbelievable. I don't know how this is going to do. Let me just think about this. This should be fine. This should work, I think. Okay, let's just copy that into the REPL instead of having to do something special. Syntax error. It's not how you do this, by the way. Okay, what did I screw up? I don't remember. Let's see. Did we probably went over matches and I still forgot. All right, let's just open the expressions thing. Isn't there pattern matching somewhere in here? Didn't we talk about pattern matching already? Functions. Labeled and optional, polymorphic. I mean, this isn't what I'm thinking. No. Where did he go over this? I guess he just wants me to use, he just wants me to use ifs, because that's what he's given us so far. I don't want to use ifs. That's not fun. That's not cute. I don't think he's actually gone over pattern matching yet. Okay. Sure. We'll go here. Advanced pattern matching. Pattern matching with let, pattern matching with functions. Here we go. Oh, okay. Wait. Did I get confused? Isn't there a way to just do this as guard like you do in other MLs, like in SML and stuff? Am I just crazy right now? I just have to find out. OCaml function guard syntax. Basic data types and pattern matching. Okay. 1 second. Where are you talking about pattern matching? Oh, it's over here. All right, Prev. Yeah, it's late. Have a good night, dude. User defined data types. Where the hell is why do they say pattern matching and then it's not over here? Why do you not have pattern matching showing right here? Let rec to string equals function. Ah, this is it. This is the syntax I was looking for. Okay, that was it. So let rec fib, you do the equals, and then you have to write out function. Let me look at SML real quick because I'm wondering if that's why I was so confused. Or maybe I was just confused and that's just life. Let's look at SML. SML snippets, fizzbuzz. Nope, I wrote it with an if. Just kidding. I thought I wrote one of these with guard syntax, but I guess I'm thinking of the Haskell I wrote. Oh well. That's how you do it in Haskell. It's probably what I was thinking of. Okay, so here you just write function keyword and then you define your guards. We do use skinny arrows. I think the rest of this might actually be correct. Let's see what happens. It has guards. I just had to have a special keyword for it, okay? So fib1 should be 1, fib2 should be 1, fib3 should be 2, fib4 should be 3, etc., etc. Okay, very cool. Fib5, sure, we'll just go for a second. Fib6, 8. Okay, it's working. How about it? Don't worry about that. Don't worry about it. Okay. And then he wanted us to do this fib 50. Let's see how long fib 50 takes. All right. Yeah, it's taking a little bit of time. How about that, college professor? That's taken some time. Okay. So now let's make this tail recursive. Where did my book go? I have too many things open now. Let's just close everything to the right so I don't get confused. Fib fast. Will seem to hang indefinitely. Yeah, that's what's happening. Yep. Create a function fib fast that requires only a linear amount of work. Hint, write a recursive helper function. Okay, we'll do this. I know, right? Especially on this computer. Okay, so fib fast is actually not going to be recursive. And it's just going to call something with an accumulator. And so we'll say something like, this is what I often do in Clojure. I don't know. I mean, I feel like it's probably more, I don't know what's like typical in OCaml. But we'll just say do fib fast. And then our accumulator. Create a function fib fast that requires only a recursive helper function int, where HNPPP is defined as follows. Equals P. Hey Ryan, what's up? Thanks for lurking. All right, are we ready to cancel our fib 50 that still was hanging after mucho time? The idea of H is that it assumes the previous two Fibonacci numbers were PP and P, then computes forward in more numbers. Hence fib n equals hn01 for any n greater than 0. Okay, so let rec do fib fast, and it takes three ints, huh? I guess they said to just call it H. Sure, we'll follow that so we don't get confused. Let rec H n pp p ppp. It's a lot of pp's. Okay. H1 ppp equals p. Okay. And HN PPP. It's kind of funny that he actually, I know, right? He basically just gives you all the answers, which I guess is fine. I guess that's fine to have all the answers. I actually think doing just a match on H might be cleaner in this case. Match one, hilarious. Match n with, I said H, I meant n. 1 P N H n minus 1 P plus P. Okay. Obviously, like, the point, I guess, wasn't to figure out the logic as much as figure out how to do this, which in that case makes this very easy. I guess the one thing that we have to do is provide this. The idea of H is that it assumes the previous two Fibonacci numbers were PP and P, then computes forward in more numbers. All right, so that's why we decrement n minus 1, right? And then it finally gets to 0, and then it's done, right? And that's why when it gets to 1, okay, when it gets to 1, then it just returns the result. Yeah. So in that case, our initial values for PP and P, I think, should both be 0. If I'm not super dumb, which I kind of might be. So we'll see what happens. We'll just define this and then say this. Okay. And then if we say fib fast 1, you get 0. That's definitely wrong. I forgot about that. Okay. So for 1, you need we're getting there. It's all right. It's all right. So obviously this needs to be 1. I should have just thought through that logically. I did not think through that logically. But I think PP being 0 is correct. Yeah, totally first try. You think it's 1 and 1, Yawar? You might be right. I'm thinking it's 0 without thinking too hard about it. Okay, well, we know that works. Let's see if 2 is 1. 2 is also 1. 3 should be 2. 4 should be 5. Oh, 4 is 3. That's not a Fibonacci. Wait, no, 4 is 3. No, that's correct. It's all right. Fibonacci sequence. I know how this works. Okay, 5 is 5. And 6 is 8. Okay, good. And then if we do 50, it should just work. Yay, TCO. How about it? It's engineer, I know. It's fine. Boom. I'm just kidding. That's all we needed. But look at, because of TCO, look at how fast we got that Stack Overflow. We got that so fast. All right. Yeah, I could assert n is greater than 0. You should be in QA. You have... I was about to say something really mean. I was thinking of like a QA tech and not like a QA engineer. I mean, there's like QA departments where like the QA department's like intense, and then there's QA departments where they're like, and there's nothing wrong with this, but you know, like kind of like they're just not developers, right? That's all I'm saying. And bad thoughts went through my head of mean things I could say to you, engineer. I'm sorry. I'm sorry about that. Okay. So sure, we could assert up here if we want to, or we can just assert here. I guess the nice thing about asserting here, well, no, but then the assert has to happen every time. QA engineer is, yeah, it's an actual role. No, that's a different role. Yeah. It's like somebody who has all the same skills as a software engineer, but they are in the business of breaking things. They're trying to break the code or break whatever you did in a more like advanced programmatic way, et cetera, right? I know you hate everything being an engineer, but what are like if you're going to call the software people software engineers, then to put a software engineer in a QA role, you think they should not be called QA engineers? Engineer gets butthurt anytime somebody calls a software developer an engineer. That's all. He gets butthurt about it. I know you don't, but companies do. So what do you want to call them? QA developers? Another reason to replace HR with AI. Yeah, I don't know. I get both sides. I understand both sides. But yeah, no, I mean they could be devs, right? They just happen to work in the business of trying to break the software instead of write the software. Yeah. No, I mean, I think engineer is definitely saying like, yeah, we have sales engineers. That's a real thing. That's a real thing. Solutions engineers, all people that are not engineers, typically, not required to have engineering degrees, right? Engineer has an EE degree, so he's just not feeling special enough if everybody gets to be called an engineer. I'm just kidding. Okay, so how does this assert work? I guess we just say assert x is greater than 0. And since assert returns unit, I can just do this. Is that correct? I mean, this is kind of the nice thing about going through this. Okay, because I actually don't know how this syntax works. Oh, I need the parens. Okay, reasonable. I just need parens. Okay, good deal. So it's the right syntax, just I need a parens. Okay. There you go. Error. Okay, cool. Fib fast. What is that gonna do? Fib fast tilde -10. Assert failure top level. What does the tilde do? I don't actually know. Fib fast. You want to do that? All right. Let's see how long this takes. 0 0 0 0 100,000. Oh, it's unary negation of int. Oh, okay. Oh, right. Because a lot of times I have to put like parens around it, right? But if I do that, I don't even need the parens around negation in general. Well, I guess, yeah, -10, yeah, is ambiguous because OCaml ignores white space, right? Okay. That was pretty fast. How about it? Look at OCaml go. Computers can do math. Who knew? Yeah, pretty good. Pretty good. I mean, my MacBook right now is like at full on. It's not really at hand warmer status anymore. It's like hand burning status. So I mean, and it can still do math so fast. we don't get Lambos in OCaml. We get lambdas. It's almost as good. we might not have Lambos, but we have lambdas. It's so close. All right. Yeah, let's keep going. I think I can go a little bit longer. 3, data and types. In this chapter, we'll examine some of OCaml's built-in data types, including lists, variants, records, tuples, and options. Many of those are likely to feel familiar from other programming languages. In particular, lists and tuples might feel similar to Python, and records and variants might feel similar to struct and enum types from C or Java. Because of that familiarity, we call these standard data types. We'll learn about pattern matching, which is a feature that's less likely to be familiar. Oh, so this is where he talks about pattern matching. Oh yeah, I tried to go there and it still didn't give me what I was looking for. It's fine. Okay, skim. Options, A-lists. Amazing list, carry on. All right, ADTs, exceptions. Okay. Lists. An OCaml list is a sequence of values, all of which have the same type. They are implemented as singly linked lists. These lists enjoy first-class status in the language. There's special support for easily creating and working with lists. That's a characteristic that OCaml shares with many other functional languages. Mainstream imperative languages like Python have such support these days too. Maybe that's because programmers find it so pleasant to work directly with lists as a first-class part of the language rather than having to go through a library. I don't know about all that, but that's fine. There are 3 syntactic forms for building lists. Nil called it. List carry on. Let's go. Oh, he even says it. Pronounce nil, a name that comes from Lisp. I think I've read this part before. Given a list, an element elt, we can prepend elt to list by writing elt cons list. All good Lisp carry-ons. First element of a list is usually called its head, and the rest of the elements, if any, are called its tail. Lisp programmer isn't convinced by lists. No. I don't know. What I wasn't convinced about is like, I mean, sure, I guess there's not a whole lot of people that I know that are reaching for linked lists in other languages that don't have first class, nice functional support for them. That's the part that I was like, meh, who's really reaching for a linked list in those other languages? I don't think very many people at this point. But what do I know? Okay, so sure, nil, cons, and then a list literal. Explains what syntactic sugar is. Very, very important. Yeah, most don't even know it's a linked list. Yeah. Because the elements of the list can be arbitrary expressions, lists can be nested as deeply as we like. Dynamic semantics. Okay, we don't care about this because I hate the way that it's explained, so we skip over all these parts. Type checking rules might be interesting. We cons a bool onto it, and the compiler infers. Sure. Talking about list type inference, it's basically what I would expect. Pattern matching with lists. Okay. So we can pattern match to compute the sum of a list using match with. We already know about match with, so we're not going to spend a lot of time on that. That is, the input list is a list of x's, pronounced x's. I mean, it is great. I mean, it's great for new people. I guess, because people might, I guess I gotten so used to this, but I guess if you're not in like Haskell, if you're not used to some functional programming things, maybe you would say XS, right? Maybe. Would somebody coming from another link, like, is anybody in chat not used to functional programming and you might see this, let rec sum XS and say XS? I don't know. It's fine. It's great. I mean, this is great that he explains the whole prime thing, right? X is prime. Yeah, all good. And then the first guard is optional. Yeah, all good. If you have to explain what to call it, maybe the name is bad. Yeah. This is how you pronounce everything. I don't know. It's kind of funny. That's funny. That's a pretty good one, engineer. All right. The multi-line format is what we'll usually use in this book because it helps the human eye understand the syntax a bit better. OCaml code formatting tools, though, are moving toward the single line format whenever the code is short enough to fit on just one line. Sure. Here's another example of using pattern matching to compute the length of a list. Okay, understood. The best way to compute the length, because if if you need to know the length of your linked list, you're probably doing something wrong. But you know, it's fine. Depends on how long it is, right? Its name there is list.length. That dot notation indicates the function named length inside the module named list, much like the dot notation used in many other languages. And here's a third example that appends one list onto the beginning of another list. Sure. We could write a function to determine whether a list is empty. Yep. All good. I'm a fan of the con syntax, of course. I like that. I think it's pretty. I don't think that's that hard for people to grasp. Head, tail. Pretty simple. Two library functions, list.head and list.tail, that return the head and tail of a get list. Because they have an exception. Let's go standard library using exceptions. And not mutating lists. Lists are immutable, naturally. This part's probably worth reading. Now, you might be concerned about whether we're being wasteful of space. After all, there are at least two ways the compiler could implement the above code. Copy the entire tail list T. I'll scroll up so people can read the code again. When the new list is created in the pattern match with cons, such that the amount of memory in use just increased by an amount proportionate to the length of T. Or share the tail list T between the old list and the new list, such that the amount of memory in use does not increase beyond the one extra piece of memory needed to store H+1. In fact, the compiler does the latter, so there's no need for concern. The reason that it's quite safe for the compiler to implement sharing is exactly that list elements are immutable. If they were instead mutable, then we'd have to start worrying about whether the list I have is shared with the list you have, and whether changes I make will be visible in your list. So immutability makes it easier to reason about the code and makes it safe for the compiler to perform an optimization. Yeah, so pretty much any sane linked list implementation that's first class is going to do that right. Pattern matching with lists. We saw above how to access lists using pattern matching. Let's look more carefully at this feature. Okay. Yeah, for sure. I mean, it's like if you're, I mean, obviously there's a lot of instances where arrays are faster, right? Each of the clauses pi to ei is called a branch or a case of the pattern match. Oh, okay. This is just explaining the syntax of pattern matching. I don't care about that right now. I don't care about that. Does he even explain that you can add a condition to the pattern match? He hasn't done that yet. Okay. Static semantics. He doesn't even explain that you could have a condition on the pattern match, apparently. Interesting. You can, right? I'm not making that up. OCaml supports conditions. Using when, I think. Is it when? Match with when? I thought that was the case. Okay. So, yep, pattern matches are exhaustive. We like exhaustive pattern matches. Unused branches, yep, that's cool. Deep pattern matching. Patterns can be nested. Doing so can allow your code to look deeply into the structure of a list. Immediate matches. When you have a function that immediately pattern matches against its final argument, there's a nice piece of syntax. Okay, this is what I was looking for before. Function keyword with a guard. Like it. Yep. Great syntax. OCaml doc and list syntax. OCaml doc is a documentation generator. He already explained this. He already went over what this is. Here is the comment for list.hd in the standard library source code. Okay, yep, already explained this, but that's fine. Okay. I mean, it's great. I actually think that somebody I mean, this book is designed for people who are new to functional programming, and I think it does a great job of being very beginner friendly. It just means that it's a little verbose, of course, for me. Because I'm so senor. Muy senor. I don't know. I mean, I kind of get what he's saying about list comprehensions here. I don't know if it's really fair to say that we just don't need list comprehensions or something like that. But that's okay. I mean, that's not exactly what he said, but it's fine. Tail recursion. Recall that a function is tail recursive if it calls itself recursively, but does not perform any computation if the recursive call returns, and immediately returns to its caller the value of its recursive call. Yep. And the rest of this is all about tail recursion, which we're good on. Okay, that was lists. Let's look at variants. A variant is a data type representing a value that is one of several possibilities. At their simplest, variants are like enums from C or Java. Yep. Except except in the case when, like Rust, you can add values to it. Let's see. We know about simple variants. Okay, so it doesn't explain more complex variants where you have values and stuff. It's just, this is a variant. It's like an enum. I did, okay, right. It is something that I have to get used to. What the hell did I just do? 3.3. Oh, okay. I went back to where I was trying to go. Unit testing with OUnit. Do I want to do this? Do I really want to learn OUnit to do a unit test? I guess we can do it real quick. Whatever. Fine. Create a new directory. In that directory, create a file named sum.ml and put the following code into it. Okay, sure. We'll just create a new directory called OUnit. Make dir OUnit. Touch OUnit. Sum.ml test, I think. .ml. Okay. And then we're literally just going to do this quickly because I don't want to spend a long time on it. I could have just, it doesn't matter. It's fine. It's fine. I already did what I did. Okay. And then we're going to put this into test. Okay. Depending on your editor and configuration, you probably now see some unbound module errors about OUnit 2 and sum. I don't have eglot actually on right now. If I did, then maybe it would say something. No current JSON RPC connection. Okay. Rude. Eglot just connect in general. Oh, that's funny. OCaml LSP is not in path. I swear I installed OCaml LSP in my Flake. Did I not? Nope, I didn't. Just kidding. Can I just put it in build inputs? I think so. I think I can just do it here. OCaml LSP is not what it's called. Big surprise there. Big surprise me naming a package wrong. I think it's OCaml-LSP maybe. OCaml-LSP? Yeah. Okay, we'll just keep reading. Create a Dune file and put this into it. Sure. OUnit Dune. Okay. And create a Dune project file as well. Oh dear. Dune project. probably not going to be super happy about all that, but I should actually have my LSP installed now. So let's just look at test.ml and we'll try this again. Still doesn't work. It's fine. I don't care right now. Yeah, it's going pretty good, Dapper King. We're just playing around with some things. Okay, so for now, let's just go into our OUnit directory. Really? Okay, I really thought I was already in. Oh, I did ... Hilarious. Hilarious. Okay. And we'll just do a doom build. Make sure this works. It works. And oh, okay. Doom build test.exe. Sure. Okay. Do anything that will cause it to revisit test.ml. Now the error should all disappear. Finally, you can run the. Okay. I mean, he's trying to explain like how to fix the issues with, because this does happen, right? I'm not doing it right now because my LSP is not working, and it's fine. But you know, like you get that, oh, modules aren't found, and you have to run do and build in order to get that error to go away in your editor. And he's just explaining that. It just seems like a backwards way of explaining that to me, but that's fine. Finally, you could run. So really, at the end of the day, what we really wanted to do is run this guy. Okay. Okay, I ran unit tests. Totally good. I don't think we really need to talk about this all that much. Run test tt main from OUnit, I'm sure, and we're running tests. These are the names of our tests, and we're doing some asserting using our sum function that is from our sum module. Glad I went through that. Not really. Okay. Don't care about this. Yeah, pretty standard. I mean, I just kind of wonder. The reason I really did it is just to see if there was any like things that surprised me. Skipping this section. Doesn't he know that this has been canceled? All right, Leandro, have a great night, buddy. Thanks for hanging out. Hope to catch your stream tomorrow. What time is it, by the way? Okay. We still got a little bit of time. Yep. TDD has been canceled. All right. Records and tuples. Let's go. How many more data types do we have? A lot. Okay. So, we'll see. We'll see. We can at least get this one. We'll at least get this one done. Maybe we'll get through a couple more. Records and tuples. I've done quite a bit of records and tuples, so I don't think I'm going to be all that surprised by anything, but we'll see what happens. A record is a composite of other types of data, each of which is named. OCaml records are much like structs in C. Here's an example of a record type definition, mon. For a Pokemon, reusing the p-type definition from the variance section. T-normal, T-fire, T-water. Type mon, name string, HP int, p-type, yep. Type p-type equals, okay, what Why are you saying that twice? Is this like an error in the book? Oh no, this is the output when you put that in utop. I forgot that that's what he always does. Okay. We're good. We're good. This type defines a record with 3 fields named. Okay, we don't need to read that. Sure, name equals Charmander. Yep. I'm just making sure that we should call him Charmander. I know that is what he's called, but I just had to make sure. HP equals 39, P type equals T fire. Yep. So your type uses colons to define typical. I mean, it fits the rest of your type annotations other places, right? If you're annotating the name of a field on a record, you're going to use colon. When you're actually doing assignment, you're going to use equals, right? Maybe I should call it Carmander to make sure that this video doesn't get demonetized. Just kidding. I don't qualify for compensation yet on videos. So in a type definition, we write a colon between the name and the type of field, but an expression. I just said that. How about that? To access a record and get a field from it, we use the dot notation that you would expect from many other languages. Yep. We can also use pattern matching for a little destructuring goodness. Yep. Love it. Looking good. A record expression is written. Oh, this is just the syntax. Okay. We already know the syntax. I don't care about your really long explanation of it. Another syntax is also provided to construct a new record out of an old record. Yep. So E is a record that you already have constructed. And here you are defining a new field or whatever. Here you are associating, as we call it in closure land, new values on your record type, your record instance. How about that? And it's immutable. Yep. We add the following new pattern form to the list of legal patterns. That looks good. And we extend the definition of when a pattern matches a value and produces a binding as follows. Sure. Tuples. Tuples use parens and commas. Very exciting. This is not mostly true. I don't know anybody that calls it a triple. Sometimes we'll call it a pair, but pretty much we just call it a tuple. But maybe this is like what people learn in CS. I don't know. I don't have a CS degree. Beyond about 3 components, it's arguably better to use records instead of tuples. Yeah, good tip. Building of tuples is easy. Just write the tuple as above. Wait, is it Elm that doesn't have tuples and is just like, you should just name everything, it's fine? Really, you should just name things because it's better. Is that Elm? I think that's Elm. Literally how they talk over there in Elm land. Syntax. A tuple is written E1, E2, E9. Okay, yeah. We got this. We know how to use tuples. Variants versus tuples and records. The big difference between variants and the types we just learned, records and tuples, is that a value of a variant type is one of a set of possibilities, whereas a value of a tuple or record type provides each of a set of possibilities. Yes. This is true. Okay, I don't need to read this. One of types are more commonly known as sum types, enum, sum type, and each of types as product types, maps, records, tuples, etc., etc. And that's why everybody loves the tuple, the tuple type in OCaml. It uses that star. It uses an asterisk because it's a product type, baby. All right. Advanced pattern matching. Let's see what he talks about with advanced pattern matching. Pattern matching with let. Okay. I think you can just, sure, this is basic let. Okay. But, okay, I'm confused. Let P equals E1 and E2. That is the left-hand side of the binding may in fact be a pattern, not just an identifier. That's a really, really confusing way to do this. Now, I understand he's just like giving the syntax, or yeah, the syntax, which is let P is your pattern equals E1 and E2. But like this just doesn't actually tell you anything. Like if you gave me an example of a pattern in the let, I wouldn't even have to read all of this prose and I would just be like, okay, he's talking about this. But just saying let P equals E1 and E2, that doesn't exactly, I mean, I get it, but it also is annoying that there's not just like a little code sample of a pattern match in the let. Pattern matching with functions. That syntax is let F P1, right? You could do patterns, sure. Function definition at top level, anonymous function. Again, if there was just like a little example, that would be helpful. Okay, here's all the examples. I guess that's fine. All right, fine. He's taking it all together to give us examples. Sure, we have our enum, we have our record. We have a match with, okay, that just shows us destructuring again. Okay, we're getting there. Match M with HP, and down to dot notation. Okay, very not exciting. It's fine. Okay, I'll get over it. Here's how to get the first and second components of a pair. First, second, sure. Third component of a triple. I feel like he just did us a disservice. Okay, let third T equals match T. Let third T equals this. Let third Z equals Z. Let third T. Okay, but what? Why am I tripping so hard on this? First and second components of a pair. Sure, those are defining functions. Oh, he's just showing that you can pattern match in the function argument. That's his point. That's his point. Because I thought, can I not do this? Maybe I can't, and I'm just wrong. But I kind of thought he already showed that we can do this, right? Yeah, he already showed that. I'm still a little confused why he did it the way that he did, but that's okay. I'll get over it. Okay. That was records and tuples. No, pattern matching advanced. And yes, I confused the crap out of myself reading that chapter. Whether that's my fault or his fault, not sure. Type synonym is a new name for an already existing type. Okay, cool. New types. Exciting. Type aliases, whatever you want to call it. I think I'm good on type aliases. And it's really short anyway. Very cool. Type aliases. I'm a fan. Options. Already know probably everything I need to know about options. Some and none, just like Rust. Type is an option. The only thing that I have to remember, and this is true of like all of your container types, is that whatever wrappers, whatever you want to call them, monads, the type comes after the value, right? So int list, int option, all those kinds of things. Sometimes I forget that. Sure. Very exciting. Options, some and none, coming from Rust. Not anything too surprising there. Association lists. A map is a data structure that maps keys to values. Maps are also known as dictionaries. One easy implementation of a map is an association list, which is a list of pairs. And this is basically what you'll see in Scheme and Racket and all of those kinds of things. We don't use alias in Clojure, though. We just use hash maps. I mean, I'm sure maybe somebody does. I don't. Here, for example, is an association list that maps some shape names to the number of sides they have. Let D equals a rectangle 4 nonagon 9 icosagon 20. Okay, very exciting. And at the end of the day, it's really just this. That's all it is. It's a list of tuples, right? Sure. I wonder how often people actually use A-lists in real normie OCaml code versus like what, dictionaries or record. I mean, for the most part, I see people, of course, like just use records. Yep. ADTs. And so they're going to talk about variants that carry data and a bunch of other things. I think this is actually a good time to call it for tonight. Let's see. What do we have left? We have this much of chapter 3 left. All that we got through today. What did we get through? Oh, we got through more than I thought. We got through 2.5 up to 2.9. We did a couple exercises. Not bad, not bad. Then we started chapter 3 and got through 3.9. We're getting there. I would say we still have probably two or three more 2-hour streams left to get through this book, but it's all good. It's been fun for me. Okay,